Hey guys, I'm going to go over a high-low method from chapter 20. Um, I'm going to do this using the example 20-3 in the book. So the problem reads, using the high-low method, Mark owns a machine shop. In reviewing the shop's utility bills for the past 12 months, he found that the highest bill of $2,600 incurred in August when the machines worked 1,200 machine hours. The lowest utility bill of $2,300 occurred in December when the machines worked 600 machine hours. And they want us to use the high-low method to calculate the variable costs and the total fixed cost. Okay, so the first thing to do when calculating the high-low method is to write the formula, and I like to use y equals mx plus b because that's what I used primarily in high school, and it's more comfortable for me. And so that's the formula, but we also need to know what does the formula tell us? What do each of the elements of the formula tell us, so that way we don't get confused putting the wrong numbers in the wrong places. When using the formula y equals mx plus b, y equals total cost, mx, that's one value, equals mixed cost, and b equals fixed cost. Okay, so that's the basis of our formula. If we solve for any of these values, then we know exactly what we're finding. So let's go ahead and try to solve the problem. The first, number one question, and that should lead us to the answer to all the other variables. Use the high-low method to calculate the cost per machine hour and the total fixed utility costs. Okay, so using the high-low method, we take the high cost minus the low cost, and then we divide that by the high usage, minus the low usage. Okay, and I'm just going to put a little formatting in there to make it clear that we're dividing. Okay, so let's put in the values. The high cost was 2,600, and that's minus the low cost, which was 2,300. Okay, and the high usage was 1,200 machine hours, and the low usage was 600 machine hours. So let's put a little formatting in there, and basic calculation equals 2,600 minus 2,300, and this equals 1,200 minus 600. So 300 divided by 600 equals 0.5. So that's the value for the variable cost per machine hour. But before we can get the variable cost per machine hour, we have to plug in the values, the high value, either a high value or a low value in the y and the x position in order to compute this number. So let's go ahead and do that. The second part is, we'll just say plug in either, and I'm going to put a star by this, either a high or a low value herring. Okay, I'm just going to choose the high because it's easier for me. So the y, the high y, we'll use the same formula, y equals mx plus b, and the high y value when total cost y was, this is the high total cost, 2600, so we'll put 2600 equals, and then what was the high usage was 1200. We have to use this rate for m, so equals 0.5 times 1200 plus b, which we don't yet know, but we're going to find that out soon. So let's go ahead and solve that. 2600, or 2600 equals 0.5 times 1200 is 600. I would put it in the Excel, but it's just easier, plus b. Okay, so now if we subtract 600 from both sides of these equations, then we'll get 2000 is equal to b. Okay, so now we know our b is the fixed cost. So let's go ahead and create the entire y equals mx plus b with these two known values. We know this is our mx, our x for the mx part, and the b is here. So now let's create the, I might be skipping to number 2, so let me read number 2, what it says. Show the equation for determining the total utility cost for the machine shop. So that's what we're doing now. Let's just write the new equation with the values that we know. So that means y equals mx, where the m is equal to 0.5 right here, put it in parentheses, 0.5 x plus b is 2000. Okay, there is our new formula, and with this formula, at any level of activity, high, low, middle, we can put in the x value, we can put in the y value, and it will calculate what the new usage is. So that's what they're probably going to ask us to do in number 3. If Mark anticipates using 800 machine hours in January, predict the shop's total utility bill using the equation from requirement 2. So now we have 800 machine hours. Okay, so let's go ahead and put that in and see what the equation comes out to be. Y in that case would be equal, the 0.5 doesn't change, 0.5 times 800 is the new mx, and our fixed cost is 2000. So y would equal 400 plus 2000 So in that case, y equals 2400. And that's the answer to number 3. So hopefully this helps you with the high-low method. It's pretty easy once you know this formula. Just plug in the high value minus the low value, and then once again the high value minus the low value. Divide those numbers to get your x, your mx, pardon me, your m for your x. And then once you have your m, plug in either a high or a low value pairing into the x and the y, and then you will get your formula. Use that formula for any future calculations. Hope this helps, guys. Good luck.